We talked previously about Boolean values, Boolean types. Remember, a Boolean has only two values. It's like base 2, a 1 or a 0, so it's either a true or a false. In Java, it would true would be just lowercase, just like it looks here, and false is lowercase, just like it looks here. This is a 1, this is 0. Okay, so I can have a method that returns a Boolean type. Remember, we talked about methods such as the math.square which returns a double. This one can return a Boolean. That's when you're trying to test a condition. For example, if I'm trying to test if this integer x is a single-digit integer, all I have to do is check if it lies between -10 and +10. If it lies between there and not equal to either -10 or +10, then it must be a single digit. So if it does, then I return the truth value of this test. Now remember, this test, if I'm doing an AND, I have to make sure this is true and this is true. I have to make sure both sides of the AND are true. So suppose I give the input number 8 as my integer x. Well, is 8 greater than -10? Yes, it is. So that means I continue evaluating this AND state. Remember, I'm not short-circuiting it. I'm continuing because I have a true here. So I want to figure out if this is true. Is 8 less than 10? Yes, it is. True and true equals true. So this function will return true in that case. So you can use Boolean methods also as the test condition in your if statement. Sometimes it makes the code more readable, more concise, and it makes it easy to do a test rather than maybe doing a lot of these more complex statements. Sometimes you may need to do something before you do the test, and that's another example when you put a condition test inside of a Boolean method. Okay, we talked a little bit about JavaDoc previously. Remember, that gives documentation on what a method does or what a function does or what a whole program does. You can also specify the parameters and their types and their purpose to JavaDoc. So remember, JavaDoc starts with /*, ends with a // It should always look like this. You'll always see this going down the sides of JavaDoc information. Even if you're not going to use JavaDoc, and honestly, we probably won't use it, but it's just good coding practice to know to put that in. So the first thing you do is, we looked at this previously, you tell what this function does. Remember, this has to immediately precede the function declaration. So here's my function declaration. Remember, it was the is single digit function from above. I didn't put the body of the code in here, but it would just be this statement. Okay, so this precedes it immediately. It tells what it does. It tests to see if x is a single digit integer. It's one parameter. I have to put that ampersand param. That's a flag to JavaDoc to say this is the rest of the information on what the parameter is. Now, this you normally shouldn't put, but I'm just saying here that you need a separate ampersand param for each parameter. That should say separate instead of separator. Okay, and then for return value, only one return value. It's always going to return true or false. Okay, so it tells you what it actually returns and under what conditions. So that's a good way to that's a good practice, like I said, to have when you're coding. Okay, and this is just another example of recursion. A really good example of a use of recursion is in the factorial function. Remember, factorial, all it does is multiply a number by successively one less each time you multiply. So if I take 5 factorial, remember that just means 5 times 4 times 3 times 2 times 1. Okay, there's no such thing as 0 factorial. There's no such thing as, well, there might be 0 factorial, but there's no -1 factorial. So really, when I'm calling factorial, I should validate first that it's a positive number and an integer. So really, I should have that in here as well, but I'm just assuming it's going to be used correctly. Okay, so how do I do the factorial recursively? Well, the first thing I'm going to test is my end condition. Am I done? If I'm done, that means n must be 1. If n is 1, I just return n. That's all I do. I don't have to do anything else. What if n is still 5? Well, that means I'm going to return, my final version of factorial is going to be 5 times, now I'm going to do factorial 4. So I'm going to do 5 times whatever factorial 4 is. Remember, that's 5 times 4 factorial. That's really what 5 factorial is, 5 times 4 factorial. Okay, so now after I call this, I'll go back up here, and now I'm calling factorial 4. I'm not done yet, so now I'm going to call, remember I have it previously 5 times, waiting in the stack. Then I did factorial 4, so that'll do, I have the previous 5 times, now I have 4, so 5 times 4, times 3 factorial, and so on until I get to n equals 1, and that'll give the value of factorial. So that's, again, that one is almost intuitively recursive, whereas other cases that we've talked about, they work, but it maybe takes a little more thinking to figure out the recursion. In this example, we'll take a quick look at the is single digit, and also the factorial, and another recursive program as well. So first thing we're doing is looking at the Java doc. So remember, it starts with /**, tells what the function does. Here's the tag that tells, here's the parameter. The parameter is x, the integer to test. The return value is true, and if x has 1 digit, otherwise it's false. So it's followed immediately by the declaration of the function. So when you run JavaDoc on that, it would put out exactly this information and showing this function as well. Okay, so let's look at it. Is single digit, just like we said. First thing, I take an integer. I'm testing if it's between -10 and 10. If it is, I return true. Otherwise, I return false. Here's the same thing, but it's more concise. In the return value, I'm just returning the truth value of this conditional that I executed. Now, remember when we talked about when you're building something, when you're first trying to debug something, it might be easier to do it this way, to code it this way, as opposed to this more concise way, because when you're here, it lets you see exactly what's going on. You might put a little print statement in there saying, yes, it decided it was true, or whatever. You may be able to look at more exactly what's happening in there. Okay, let's see. We looked at factorial. So remember, factorial, the first thing it does is check if, this checks if it's 0. Because you could go down to 1. You can go down to 0. As long as you're returning 1, you're still going to multiply it by 1, and either case, you still get the same answer when you multiply something by 1. So if it's not 0, or if it's not 1, either way it should have worked, then I'm just going to do factorial of 1 less than the number. Remember, if I do 5 factorial, I have to do 5 times 4 times 3 times, and so on. So here would be my 5, and here would be the factorial of 4. So remember, 5 factorial is the same thing as 5 times 4 factorial. So that will continue, in this case, until you get to 0. I could have put a 1 there. It should have worked correctly as well, because multiplying by 1 has the same effect either way. Okay, another quick example we're going to look at. I don't know if you remember the Fibonacci sequence. Remember, that shows up in nature, number of flowers, number of petals on a flower, number of arms on a starfish, number of arms on an octopus. A lot of things in nature show up as Fibonacci numbers. So anyway, the Fibonacci sequence starts out with a 1. The second in the sequence is a 1 also. So the first element is a 1, the second element is a 1. After that, you start adding the 2 previous elements to get the next element. So if I want the third element, I add the first 2. I add a 1 and a 1, I get a 2. If I want the fourth element, I add the 2 previous, which are 1 and 2. I get a 3, and so on from there. So what I'm doing is, if I'm looking at the first element or the second element, by the way, this function will return the nth element in the list of Fibonacci numbers. So if I'm looking for element 1 or 2, it just returns 1 because the first 2 are 1. Okay, after that, it returns the previous element plus the one before that. So it's the sum of the 2 previous elements. So that one makes sense. You're returning the sum of the 2 previous elements to get the nth element. So we can see how this runs. Let's see. Okay, so let's see what happened here. The first thing I did, the first thing we're doing here is I'm printing out, is 2 a single digit? True, it is a single digit. I set a flag that checks if 17 is a single digit. Remember, that was the same exact thing, except the same exact as single digit, except it did it more concisely. So big flag is meaning if it's not small, then it must be big. So I check if 17 is small. If I get false, I want to negate this to say it's big. So in this case, well, actually we didn't do anything with that. We're just doing an example with it. So here, now I'm doing another example of that. I'm checking 9. Is 9 small? It should be. It's a single digit. So I printed out Z was small. It works correctly. Now I'm doing factorial. We did factorial of the number 3. So that should be 3 times 2 times 1. I get a 6. I'm looking for the third Fibonacci number. Remember, the Fibonacci numbers go, the first element is 1, second element is 1, Third element is 2. And so when I run the Fibonacci function with the argument 3, I want the third element or in the series. It should be 2. And there's my answer 2.